Hello guys, this is lead code question number 2, add two numbers. This is a very interesting question. In this question, we are given with two non-empty linked lists, right? So we are given with these two lists in example 1. The first list is 243 and the second one is 564. And what we have to do is that we have to add these two numbers which are stored in a reverse order. Basically, if the number is 342, so inside this linked list, it is stored in a reverse order, that is 2, 4 and then 3, right? Similarly, if the number is 465, then it is stored in the reverse order inside the linked list, that is 5, 6 and then 4. What is our task? So our task is basically to add these two numbers and return sum as linked list, right? So if these two numbers are there, then we have to add, and the list, the final list, which is sum of these two lists, also in reverse order of course, will be returned back from our function add two numbers, right? So there could be two approaches that we can use here, but first of all, let's understand that how these two reversed order will help us, right? So they're saying that these are two lists and these numbers are in reverse order, right? So the very first approach that you can use is a very simple one, obviously. So that could be that read the first list, right, and form the exact number, form the original number, right? The original number after reading this list would be 8, 9, 6 and 2, right? And you can store this inside an integer, right? Integer variable instead of linked list. So you have read a linked list, you have extracted the number, you have stored it inside a variable which is of type int, right? Similarly, the same thing you can do with the next number, that is 9, 7, 0, 8 and 4. You have extracted this number from the list, stored it inside an integer variable, and now you can add these two numbers. A new number will be formed which will be 2 plus 4 is 6, 8 plus 6 14, then 9 plus 1 0 10, then 8 plus 8 16, and then this number will be formed, that is 106046. Now what you can do is that you can basically, using the mathematical operation of division and mod, these two operators you can use, and you can again make a final list which will be a new list basically, which you're creating again and again. You can start basically you can create a new list like this, which will be having all these numbers, right? So 1 0, then 6, then 0, then 4 and then 6, and now this new head can be returned, right? This is a very simple approach, of course. So this also you can do, but I want to tell you a new approach. Basically, I'm not going to start with this approach. Why? Because it will be a very long video if I'll start implementing both the approaches, because the second one is quite important. What happens is that in this particular approach, we are basically going to traverse through this list in some OM time, right? Then the second list will also take some OM time, right? Based on the N and M being the length of the lists, right? And of course, after adding, we again have to create a new list, right? This new list, either you can use the spaces of L1 or L2, right? Because they're already created. So either one of the lists you can use, or otherwise you can create a new list altogether, right? That's up to you, of course. But if you're using the existing list, there'll be very less memory usage, extra memory usage. But of course, if you're creating a new list, then some big O of M plus m slash n plus some constant space that is used for some carry operation or something can be required, right? So it will be only a one space, but of course, so big of one, some constant space, that's why I'm saying. But of course, some extra space can be required, but that's okay if you're using some existing space. The only thing is that you are basically going to iterate through these two lists, right? So this you can consider as a task to be done by yourself. I'm going to start with the next method, right? That is approach number 2, which we can use in this case, which will be using recursion, right? Or either you can use iteration also, that's up to you. But herein we're going to use recursion because of the simplicity that it offers, of course. So let's just start with the recursive approach for it, right? So one of the approach we have discussed, but we are not implementing. And the second one, which we're going to implement also, is now what we are going to start discussing with. And why are we going to discuss that is because of the reason that many of the questions can be solved very easily using this technique, right? So it will save your space, and it is going to iterate, or it is going to take time complexity of the bigger of the list, right? The list which is bigger in size, that will be the time complexity for this particular algorithm. So it will not iterate m plus n times. Basically, this is what I'm saying. So approach number 2, let's discuss that, right? So this is approach 2, right? So what is going to happen is that we are going to start in a recursive manner, right? So at each step, what we're going to do is that we are going to start with these L1 and L2, right? So initially L1 is pointing to 2 and L2 is pointing to 4. Okay, one more thing that we'll be discussing while solving this, while discussing this approach only, we'll see that, right? So right now L1 is pointing to 2 and L2 is pointing to 4. This is the very first recursive call, right? This is the very first recursive call. So in this, what we're going to do is that because both of the L1 and L2 are not null, so we are just going to add, and we will be calculating the carry also, right? So right now carry is equals to 0, right? Because it is not greater than or equals to 10, the sum of L1 plus L2. So what we're going to do is that we'll pick L1 list, right? And we'll update this list only. So we'll say that L1 is equals to 2 plus 4, that is equals to 6, because there is no carry. So we'll forward c equals to 0 to the next call, right? So we are basically calling the next function recursively, and this time we have passed c is equals to 0. Here also c was 0 because this was the very initial call, right? In the second call also we are passing 0 because from here we cannot get any carry, right? And at the same time, the next thing that we will be doing is, and yes, one more thing that we have to keep in mind is that we are updating L1. Okay, so here we are waiting for a next node to be node to be updated. Basically, from here we have made a call to the next recursive function, right? Whatever will be returned from here will be added to the next of L1. Right now 2 is added, right now 6 is added, right now. So we have called this next function recursively, wherein we have passed 3 arguments again. These arguments are L1 dot next. So L1 dot next basically is pointing to 6 now, right? So in this particular recursive call, L1 will be pointing to 6 and L2 will be pointing to 8, right? So we have we are in the next recursive call wherein L2 is pointing to 8 and L1 is pointing to 6, right? And one more thing that we have passed is a carry, which is 0. So again we'll be calculating the carry. So the carry will be equal to 6 plus 8 plus 0 and divided by 10, which is equals to 1, of course, and the sum is equals to 6 plus 8 plus 0, that is 14, right? But of course we cannot contain the whole 14, so we'll mod divide it by 10 and we'll get a 4, right? So again we are going to update this L1, right? So L1 will be equals to 4. So what we are doing here is simply we are just changing the values in L1 list, right? So L1 right now is with the value 6. In this place where L1 was 6, now we have updated this 6 with 4, right? And now again we have made a next recursive call wherein L1 dot next is waiting for its next argument, basically, right? So we have passed this time again we have made a recursive call for 9, right? So L1 will be pointing to 9 in the next call and L2 will be pointing to 0, right? So L2 is 0 and L1 is 9, and this time this carry that we have passed is 1. Okay, these 3 arguments we are passing again and again. Again we'll calculate a carry. So 9 plus 1 is 10, so the carry will be equals to 1, wherein the sum that we have to store inside this L1 will be 0, right? Because 9 plus 1 is 10, so we can store 0 inside this node, right? So right now L1 will be equals to, this particular local L1 will be equals to 0, and again we'll made a recursive call. So in the next recursive call, the argument that we are passing is for L1 it is 8. So right now L1 is pointing to this place and L2 here, and L2 will be pointing to 7, right? And the carry is equals to 1 again. Again we'll be calculating the carry. So carry will be 7 plus 8 plus 1, that is 16, of course. So 16 divided by 10, which is equals to 1, and the sum will be equals to 16 mod divided by 10, which is equals to 6, right? So L1 is equals to 6, and now we are waiting for the next. So next, when we pass, so L1 is equals to null, wherein L2 was equal to 9, right? So because L1 there's nothing left, wherein here we have one more node, so L2 we are passing as 9. Now carry that we have forwarded is of value 1, right? Again we have this c equals to 1 that has been passed in our arguments, of course. So now what will happen is that we will again calculate the carry. This time again carry is equals to 1 because 9 plus 1 is 10, so carry is 1, and the sum for this particular node will be 0, right? But you can see that there is no node here because we were updating the L1 list only, right? We chose it because we don't want to waste any extra memory. So we thought like it will be a better option to just update the values of L1 only, but there is no node here. So whenever this case will arise wherein we want to have a node but there is no node possible, so what we can do is that we can take this particular node, right? So at this particular moment what we will be doing is that we'll be updating the L2 node, right? Why? Because L1 is not present only, so we'll be saying that L2 is equals to 0, and carry for the carry which we have to forward in the forward direction to the next recursive call would be 1, right? So again we'll be waiting, but this time when we passed the next node, L1 was equals to null already, and this time L2 was also null, but this time a carry was there, carry was forwarded, right? That was equals to 1. So at this particular moment we'll be creating a new node, okay, and this node will be updated with 1 because there was nothing nothing else to add, right? So this carry equals to 1 is there. So for that purpose, because there was no list which was greater than, which has the capability of holding this extra carry, right? So we created a new node, and this new node is what we are passing we basically will pass the reference to the calling node. The calling node was L2 in this case, right? So L2 will be given this node in return, and what we will be doing next is that we'll attach these two nodes. So we will be writing something like this: L2 dot next is equals to whatever is returned back, right? So here what we have done is that we have created an extra node with the value 1, and we have returned the reference to this particular node to this L2, right? The L2 that was here in this particular call frame, right? Stack frame, and we have attached these links here, right? Similarly from here we will be returning the L2 because we have attached onto L2 this temp, so we'll be returning this L2 to the caller, right? When we did that, so what will happen, 8 will be attached to this 9 this time, okay? So this 9 was what was returned from this particular function, and we made a link here. So here what we have done, that this is coming here, so L1 dot next is equals to the link that was coming. So we have attached this link here, and now we'll be returning this L1. So this L1, that is, we are talking about this one, right? So this particular node's reference will be returned back to the caller, right? Every time we have to pass the reference, so this reference has been passed to this particular L1. So again we'll be attaching this list to the caller. The caller was 9, right? So to 9 we have attached this link. Again we'll be returning the link of this 9 to 6, right? And again L1 dot next was waiting for this link to come to get attached to it. So again this link is formed, right? Similarly with 6 the link has been formed, right? This time it's 2 which was waiting, right? So up till here the things are done. Now we have returned this 6 link reference to 2, and this link has been attached. Now if you'll see, this whole new list has been formed, right? And everywhere if you'll see, the values were updated already. For example, this L1 was overwritten with 6, right? Because we have done that part already. So it was 6 here, right? This L1 was overwritten with 4, so here 4 was present, and this L1 was written with the 0. So instead of 9 we can say that 0 was written over there, and this 8, instead of 8 6 was there, right? Here 0 was there, and at the end 1 was there. So this new list has been formed, wherein we have not used any extra space unless it is very much required, right? So that is the reason that the memory, this code will be very memory efficient, because we are using an existing linked list, right? So the one which will be bigger anyhow, that much length of the resulting list will be there. Plus, if there is any extra carry, then we have to take care of that particular carry, right? So only one extra node could be there in some cases, otherwise it also won't be there, right? So we can solve this problem in one traversal, and we can say whichever is bigger, right, that much time will be needed, right? Time complexity you can calculate in this way. So if we'll go to the implementation part, let's go to implementation part and check that how simple this code would be. And I hope that the flow is clear, like what is our approach, that part is clear. Now we just have to look into the implementation part. So let's start with that. And you can comment below about the approaches. If you feel like that the first approach should be discussed as well, so I can make a different video for that also, right? That is not a big deal, but I just was trying to give a very efficient approach, and a video of longer length is of no use because somehow we cannot reach to the part of the video which is quite important, right? So I want to give this glimpse of technique to everybody so that you can make sure that okay, this is how we can work as well. So let's start with the implementation part. So because we need a carry, right? I'll be very descriptive while writing the solution. So initially the carry is 0, of course, and let's make a new function called as add numbers maybe, right? So this is the add numbers function which we're calling. And within add numbers, we are passing initially L1 and L2. That is the very first nodes, like 2 and 5, we are basically passing. And with that, a carry of 0 is been passed, right? And the resultant list node that will be returned from this function is what we are returning from here also, right? So now let us go to the implementation. So what is happening is that list node add numbers is our function, and it is returning a list node, right? And within it it needs 2 parameter that are list node L1 and L2 plus one more parameter that is a carry, right? So there can be 4 conditions that can arise here. The first condition is if L1 equals to null and L2 is equals to null, right? This can be a first condition. Second condition could be L1 is equals to null, but L2 is not equals to null, right? And else if the third condition could be just L2 is null, right? And fourth condition is, and I'm writing it in it to be a bit descriptive, but of course the fourth condition is that L1 and L2 both are not null, right? L1 is not equal to null. You can just use else also. You don't need a else if in this last condition, because that is the only possible fourth condition. But to be a bit more descriptive, I will be writing it here. So L1 is also not equal to null and L2 is also not equal to null. For that case, we are writing this particular fourth case, right? So we are saying that if L1 is not equal to null and L2 is also not equal to null, right? For example, 2 and 5 we have passed. So what will happen? First of all, we'll be calculating the carry, right? So int c is equals to L1 dot well plus L2 dot well, right? And plus carry, of course, and divided by 10, right? This is what our carry would be, right? And eventually you can you don't have to even divide it by 10. You can just say that if it is greater than 10 or equals to 10, then the 1 will be the carry, otherwise 0 it is, right? So you can write the logic as you like. So divided by 10, the carry will be inside the C. And afterwards, because we have considered L1 to be our initial list in which we are updating everything. Otherwise, if you want, you can choose L2 also. That's also up to you. Because anyhow, we don't know that which list is bigger at this particular point of time. So we'll consider L1 to be a parent. So L1.val is what we are updating right now. now we're saying that L1 dot val is equals to the same sum but mod divided by 10, right? So here we are updating it by with this particular value. And now what we want, after updating these all values, now we're going to call our add numbers recursively for the next two nodes, right? So now we'll be passing L1 dot next and L2 dot next, right? And we need a carry, but we have calculated the carry already, so here we'll be getting that carry, right? And one more thing that we'll be doing is that L1 dot next, we want to make this connection also. So whatever add numbers is returning, we want to add it to L1 dot next, right? And afterwards we'll be returning this L1. So after attaching the node that is coming from the call which has been made here, right, in the right hand direction, so it will return some node. We are connecting it to with L1 dot next, and afterwards we are returning this L1 to the caller function, right? So in the very initial step, in the very first step, whenever this particular function will return, right, for 2 and 5 basically I'm saying, that will be a final answer, right? So okay, we'll discuss that afterwards. So first of all, what will happen next? Next you'll be passing L1 dot next, L2 dot next, right? So in some cases what can happen, that L1 is equals to null but L2 is not equals to null, right? So in such cases again we have to calculate the C, of course. It is basically the carry, so we have to calculate this carry, right? But this time, because okay, so we have to calculate this carry, but because L1 is equals to null, so will L1 dot val will not be existing, so L2 dot val plus carry will be the final answer, right? And because L1 is already null, so we cannot update L1 dot val, of course, so we have to update this L2 dot val, right? And which will be equals to L2 dot val plus carry mod divided by 10. This will be the L2 dot val, right? Now what can happen is that again there could be a carry, right? Here also a carry could be there. So if C is not equals to 0, right, there is a carry, then we have to make a next call also, because maybe we'll have to create a new temp node, that is the end case which we have discussed, right? So for that reason we'll be calling this add numbers function again, and this time because L1 is not existing, so we cannot call L1 dot next, we just have to pass L1, which is null again, and L2 dot next we can pass, right? And of course with C we have to pass this C, this new C that we have calculated, right? From here some some node will be returned, which we will be attaching to this L2 dot next, and afterwards we have to return this L2, so return L2, right? The similar case would happen. So if suppose C is not equals to 0, then we have to make this whole call of add numbers and all such things. But if C is equal to 0, then we don't have to go any further, even if the list is having a lot of other numbers or a lot of other nodes, but because there is no addition of carry that is needed, so we can just stop the process right here and we can return L2 from here itself, right? When the same case will be followed for L2 equals to null also. So here again, if L2 is equals to null, the same thing we have to calculate, but this time keeping in mind that L2 is null and L1 is not null, right? So again we'll be calculating the C, which will be equals to, okay, I can copy paste this whole code, right? It's just that L2 will replace L1 and L1 will replace L2. So L1 dot val will be there, L1, right? L1 dot next, here we have to pass L1 dot next because L2 is already null, so we cannot pass L2 null, L2 dot next, and here we'll be returning L1. So it is the same code as this previous one, right? Afterwards the last case is that when L1 and L2 both are null. So in this case, in this particular case, we have to check if carry is equals to 1 or not. or otherwise we can just write a very generic case, that is if the carry is greater than 0 or not, right? If it is greater than 0, anyhow we don't have anything to add with carry, so of course we can store it in a single node. There is no possibility of other carries because it is a single number, of course. So what we're going to do is that we are going to create a new node this time. Okay, so new node is equals to new list node, right? We can name it as a temp node also, it will make more sense. So temp is equals to list new node, and we have to instantiate it with the carry itself. That is, we have to pass carry as the value, right? Here we have some constructors wherein if you'll pass a val, this val will be this val of list node will be initialized with the value you're passing as argument. So as argument we are passing carry, this will initialize the val of list node, right? So this is done, and we can return this temp from here, right? And if the carry is not equals to is not greater than 0, then you can simply return a null. Then you don't have to work on different things. So this is it. This is the whole concept here. So let's test it and let's find out if it is working fine or not. If there would be some problems with the test cases, we'll check individually that what are the problems that are coming, right? So for example, line 42, return statement is missing. So let's check it out. So of course this is happening because we haven't written an else statement, so it is seeking for the cases wherein none of the case would follow, but we know semantically that could not happen, but because of the syntax we have to write here something. So if you'll not put this particular condition here and just write else, you won't have to write this return null here. So now run it again. Okay, all the 3 test cases are passing. So now let's submit the code. So see, runtime of 1 millisecond, which is quite good. So now your task would be to try the first approach also, right? Because that is also a good approach. It is not like it will not work, but this is a more efficient approach. So you can try this one also, right? Eventually the variations could be of memory. Like if you want, you can create a whole new list also. So that will be a very easier version of this, because right now we are just updating the existing list, so we are not using any extra spaces, right? But if you'll create a new list, it will be hampering your space complexity. So keeping in mind that time and space both should be efficiently used, this algorithm is a good to go kind of a thing. So just let me know if there's any doubt, if any further explanation is needed. I'll do that bit from my side. Otherwise, thank you guys, and do let me know that what all problems would you like me to solve for you. So yes, so like and subscribe if you like the video.